All right, guys, this is 8.5H. This is identifying examples of proportional and non-proportional functions that arise from mathematical and real-world problems. So this is pretty much the same stuff we've been doing, except now it's going to be like real-world situations. All right, I'm going to go over this example first real quick, this multi-step example, but I don't like it. It's a really dumb question. It's very misleading, so we'll go through it real quick. Okay, it says Marta's profits. All right. It says Marta's profits from selling lemonade is given by y equals 0.6x, where y is the profit in dollars and x is the number of glasses of lemonade sold. Okay, so that's her function. Her profit is y, and her uh, equation is 0.6 times x, where x is the number of glasses of lemonade sold. Justin's profits are shown in the table. Describe how the profits compare for 40 glasses of lemonade sold. Okay, so for Justin, they didn't give us a function, they gave us a table. Okay, so what they did is they looked at a table. They have glasses sold, let's put GS, and they have profit, which is money. Okay, so here they put 10, and then here they kind of try to mislead you. They put 2.5, which should be $2.50. So if you want to change it, change it. If you don't, don't. Okay, it doesn't really matter. Um, and then it goes on to 15 and 6 1/4, 20 and $10 profit. And the last one is 25 and $13.75. Okay. So for Marta's profit, this is Justin. So I'm just going to put Justin. Okay. So that's Justin. But for Marta or Marta, it said that hers was y equals 0.6x. So this is the number of cups sold. This is her profit. So this has to be how much she sells each one. 0.6, again, it seems a little misleading, but it's 60 cents. Okay, so you have to make sure that you understand that the decimals here, this is the tenths place and this is the hundredths place. So if you want to add that zero there to make it more understandable, do it. Okay. So for 40 cups, I would replace that with 40. So I would go y equals 0.660 times 40. Okay. So if we multiply that, I get y equals 24. So this is how much money she makes. She makes 24 bucks. Okay. So that's how they get the number for Marta. Now for Justin, it's a little trickier. So Justin, they gave us a table. They didn't give us an equation. So we have to find a pattern. So for every there is a pattern up here. It's going +5, +5, and +5. Okay. Um, that's very important because for every 5 glasses, we have to see if there's a pattern here. Okay, which there is. It's point or plus $3.75 each time. So that tells us that for every um, 5 glasses, this guy Justin makes $3.75. Okay. So in order to get to 40, I would have to go another 5, which would get me to 30. So +5. So that's 5 number one. And then to 35, and then one more to 40. Okay. So that's 3 plus 5s. That's number 2, and that's number 3. Okay, to get to 40. So that means I would have to do the same thing here. 1, 2, and 3 to get to whatever this is. Okay. So that's what I have to do. So he already has 1375 in profit. So I'm just going to put 13.75. And then I'm going to add more profit, the 3 times that he did. So I'm going to put 3 parentheses 3.75. Okay. So again, this is what he had already made according to this, because he had sold 25 already. He had already made $13.75. And now we're adding the 3 more jumps that he does. This one, this one, and this one. Because to get to 40, we have to jump 3 more times. So we go +5, +5, +5. and that'll get us where we want to be, 40. Okay, so that's going to give us, well, this one stays the same, so I'm going to 13.75 stays the same, and this times this comes out to 11 and 25. So now we add those two together, and we get 24 and 25, so we get 25 bucks. So this guy, Justin, makes $1 more than Marta because he makes 25 and she makes 24. Okay. I don't like this example at all because there's you. I mean, if you look over here, glasses sold 20 and 10. You can divide that and get that he sells them for 50 cents each. This tells you that he sells them 50 cents each. This one doesn't. This one tells you that he sells them for a quarter. So there's no set pattern on him. There's no, like her, she sells them for 60 cents each all the time. This guy doesn't. He sells them, I don't know how his prices are different, but they are. Okay, so that's why we have to start from the end of his table and keep it going to find out how much exactly he makes. Okay. All right, so that was that example. Okay, so let's go over example number 1. Just so we can look at a better one. Let me go and resolve this. All right, so for example number 1, it's asking for, remember, these are trying to see if the situation is proportional. Proportional looks like this, where it starts right there at 0 and 0, like that. Okay, so that could be anything. That could be like hours worked and dollars. So if you work no hours, you're not going to get any money. Okay, so that's what that means. That's a proportional situation. If I don't show up to work, I don't get paid at all. That's proportional. Okay, whereas if I had, I don't know, let me another example, like a plumber. So if we have a plumber, for his hours worked and his pay, well, he doesn't start at 0, because the second you call the plumber and he's already driving to your house, you already owe him money. So let's say he starts here like at 80 bucks. Okay. And then from there, as he works, he makes more money. Okay. So his graph goes like that. So his graph is not proportional because he doesn't start at 0. He starts at $80 just because he showed up to your house. So he's already charging you money. Okay. So that's the difference between a proportional situation and a non-proportional situation. Okay. So we have to read them carefully to see if it's going to start at 0 or not. All right. Number 1. The relationship between which two quantities is an example of a non-proportional. So just like the plumber, okay, we want non-proportional. We want a graph that goes like that and starts here, not here. Cannot start here this time, okay? A, total distance traveled and number of hours traveled if John drove his car at a constant rate of 60 miles per hour for 2 hours. So total distance and hours. Well, you have to ask yourself, if he drove 0 hours, does he drive 0 miles? Okay, well, sounds like he does, right? If he's not doing anything in the car, he's not traveling. So that can't be it. That would be a proportional. B, total earnings and number of hours spent babysitting if Carrie babysat for 4 hours at a rate of $8 per hour. So again, if she babysits for 0 hours, she's not going to get paid. Okay. C, total fees charged and number of carpeted rooms cleaned if a carpet cleaning company charges $40 for the first room and $25 for each additional room. Okay, so this guy's charging $40 for the first room and $25 for any additional room. So he's never going to start at 0. He charges 40, so let's say that's 40. And then each one is going to be plus 25. So let's say that the next one is going to be 65. That's 40 plus 25 is 65. So one extra room would be right there. Okay, so that's not proportional. So that might be the answer. And D, total savings and number of weeks spent saving if Jeremy saved $10 each week for 6 weeks. So he's saving $10 a week for 6 weeks. Before he even starts, he has no money. Okay. It doesn't say that he had money saved up already. It just says that he started saving, so he had zero. So at 0 weeks, he has $0. So that is proportional. So for this one, the answer is going to be C, because it is not proportional. He starts off at $40 for the first room and adds 25 for each additional room. Okay, so that's what you got to look for on these problems. Okay, so just read them real carefully and make sure you understand.